Here we're going to talk about an inverse square variation or relationship. And there's so many things that behave like this in the universe, in our world. One thing is radiation. Radiation is an inverse square variation. In other words, the intensity of the radiation varies inversely with the square of the distance. So several years ago, when the tsunami hit Japan, and there was a nuclear power plant that was jeopardized, and the radioactive result of the nuclear material at that site people were exposed to that. And the question is, how close could what was a safe level to get? How close? And to figure that out, well, they know what the safe intensity level of the radioactive material is. Whatever that number is, and depending on if it's plutonium or uranium or whatever, they each have a different value of K. But then you can just figure out what the safe level here is, plug in this, then you can solve this for D. And you can figure out exactly what is the safe distance so that the intensity is not any more than that. Whatever that distance is, you can then figure that out. But that's an inverse square variation. A lot of people don't realize, but when we work on computers, when you're in front of a screen, the screen emits radiation. And that's why we don't want to be our face too close to the screen, because the further away we are, and because it's a square relationship, you don't have to be that far. 12 centimeters, notice the intensity is 1/144. It's 1/144th is intense, yeah? So you don't have to be that far away, but that's another example of why you don't want to be close to the screen, because it does emit radiation. And radiation is an inverse square relationship.